A very good morning to all of you. As I've already been introduced, I'm Dr. Ritula Thakur, Assistant Professor in Electrical Engineering Department. And today I'll be giving you a basic idea or an introduction to the word of hybrid power flow controller. Since this course is based on facts and distributed generation, Anjali ma'am has already told you about the various fax devices. This lecture is basically about hybrid power flow controller. I will not be going into much detail of the other controllers because they have already been discussed. But firstly, to have a background, let us revise the classification of fax devices. The fax devices, either they can be shunt or series, or else they can also be classified into two types, that is variable impedance type and voltage source converter type. In variable impedance type, we have various type of converters, but mainly which are used, one is SVC, that is static wire compensator, and the other is TCSC, that is thyristor control series compensator. Now, as the name also implies, these are based on the principle of variation in the impedance, because our main aim is the active and reactive power flow control. So this can be either achieved by variable impedance, or else the other type of fax controllers which are used, they are based on voltage source converter based, that is VSC. So you must be recalling that in the first day, Shimi ma'am had given you an idea about what are the voltage source converters. So these type of fax devices are basically based on these VSC only. They are nothing but three-phase voltage source converters, and the main converters are STATCOM, SSSC, UPFC and IPFC. And Anjali ma'am told you about STATCOM, SSSC and UPFC today. Now, before going to HPFC, let us have a basic idea about what UPFC is, because what we have seen the various advantages of unified power flow controller as discussed by Anjali ma'am. Now, although, yes, we have seen that UPFC, it is a combination of series and shunt type of VSCs. So it basically utilizes two voltage source converters. One is in series and the other is in parallel. So basically there are two VSCs which are connected back to back, and they are operated from a common DC link. And the real power, it can freely flow in either direction between the AC terminals. This you have already been told. And both the VSCs, the voltage source converters, they can independently generate or they can independently absorb the reactive power. And the series VSC, what does it do? It basically converts the excess of real power of transmission line to the common DC bus, and it supplies or absorbs the real power. And the shunt connected converter, what does it do? It converts this common DC link power demand by appropriate generation of the voltage magnitude and the phase. So basically, in the case of voltage source converters, the basic idea is injecting voltage into the line. Now, either this voltage magnitude can be greater than the line voltage magnitude, or it can be lesser than the line voltage magnitude. Accordingly, it will be generating or it will be absorbing the reactive power. This is the main basic principle of the working of voltage source converter based fax devices. And about the real power, it generates or it absorbs the real power by making the voltage phase difference with the current. That is the basic principle. And either shunt or series, independently they either work on the active power or they work on the reactive power. But the UPFC, it has the advantage that it is capable of controlling all the power flow parameters V, delta and X either simultaneously or selectively. Why we are saying selectively is because you have a common control in this case. You have a shunt controller, you have a series controller, but you have a common control in this case. So either you can selectively control these parameters, or else you can simultaneously control all these parameters. So what happens is, because of this, you have a superior power flow control in case of a UPFC. Another thing is there is no restriction. Yes, it helps. Another thing is that there is no restriction of the direction of the voltage phase angle and voltage magnitude. So this is the unique feature. That is why the name unified power flow controller. I'll not be going into much detail because in the morning session you've already been discussed in detail all these things. But because the DC common link is open, so it can be operated either as SSSC or STATCOM independently. And as I said, that separate source of sync is not required for the real power exchange. But these, we were talking of the various advantages of UPFC. Now coming to the disadvantages of UPFC, because these disadvantages of UPFC make the foundation for our controller, which we are going to discuss today, that is HPFC. The main disadvantage of UPFC is that two VSCs are required. Why? Because one is shunt and the other is series, and both of them require one voltage source converter. And especially for transmission voltage level, these have a very high cost. This is the main deterrent in the application of UPFC. Although we have seen that UPFC provides a very superior power control, because you are simultaneously able to control all the parameters like V, X, delta, etc. But the main hindrance in the application, or we can say that in the real implementation of UPFC, is the high cost, because you are requiring two separate VSCs, one for the shunt and one for the series. And because of this, the overall cost of UPFC and hence cost per kVR generation is very high. This is the main thing. Another thing is, see, fax devices are not a replacement of the classical equipments. They are an add-on to the classical controllers. But the existing equipment such as switch, capacitors, SVC, TCSC, they have to be decommissioned and replaced. So what is the solution? Solution is that if we are able to devise such topologies which make use of these existing equipments in addition to our fax device, other like VSC based controllers, then that will reduce the overall cost. Because अभी क्या हो रहा है कि आपका जो आपको एक्टिव रिएक्टिव पावर एब्जॉर्प्शन के लिए या जनरेशन के लिए जो आपके क्लासिकल कैपेसिटर्स या रिएक्टर बैंक्स लगाने पड़ रहे हैं, यूपीएफसी में उनका कोई यूज नहीं था. In case you have to make of a UPFC, आपको दो अलग अलग separate voltage source converters का use करना पड़ रहा है, which is overall increasing the cost, as well as existing equipment they are becoming of no use. So अगर हम ऐसी टोपोलॉजी एक फैक्स डिवाइस बनाते हैं जिसमें आपका existing equipment like switch capacitors हो गए या SVC हो गया, ये भी use हो जाए और आपका एक VSC भी use हो जाए, then that will reduce the overall cost. And it will give us the basic advantages of a UPFC as well. And that is nothing but the HPFC. That is hybrid power flow controller. Now, why is it called hybrid power flow controller? Because hybrid. So, hybrid में क्या हो रहा है कि आपका जो static devices हैं, वो भी use हो रहे हैं. Plus, in addition to that, we are also making use of the voltage source converter. So, that is why the name is hybrid power flow controller. And its main advantage over a UPFC is the overall cost is less. Now, various topologies of HPFC have been discussed till date. Out of all these topologies, I will be taking one topology, और वो उसके हम जो MATLAB simulation results वगैरह देखेंगे, and we will see that these are very comparable to those of the UPFC. ठीक है? And for those who are interested in going into more details, I will be telling you बाद में इसके कि what all research scopes you have for implementing the HPFC. But firstly, let me give you a glimpse of what basically it is. So these are the various advantages of hybrid power flow controller. What does it do? It basically comprises of two half-sized VSCs. आपकी UPFC में क्या था? You had two different voltage source converters which were adding to the overall cost. But इसमें ऐसा नहीं है. इसमें क्या है? You have two half-sized voltage source converters and they have their DC links connected back to back. Plus one thyristor control variable impedance type fax device. So how is it hybrid? It is hybrid in the sense that you have one variable impedance type fax device as well, and you have one VSC based as well as. लेकिन यहाँ पे क्या हो गया? Instead of having two different VSCs, we are having two half-size VSCs. ठीक है? So that means you have a reduced rating as compared to an equivalent UPFC. This is the advantage of HPFC over UPFC. And similar to UPFC, you will be able to simultaneously and independently control the active and reactive power. So all the advantages of UPFC are there in HPFC, plus an additional advantage of the reduced cost. So if the existing line needs to be upgraded, So you need not decommission the line, because अगर आपको एक यूपीएससी को इम्प्लीमेंट करना है तो आपको क्या करना पड़ेगा कि आपका जो एग्जिस्टिंग एसवीसी वगैरह है उन सबको आपको डीकमीशन करना पड़ेगा. बट इन दिस केस यू विल बी यूटिलाइजिंग द एग्जिस्टिंग इक्विपमेंट. इन एडिशन टू दैट यू विल बी यूजिंग 2 half sized voltage source converters. This is the basic of your HPFC. Okay. As I said, biggest advantage is the cost effectiveness, and what you're doing is it enhances the dynamic performance of the variable impedance type fax devices with a coordination with voltage source converter based fax device. So if we go to our first slide जिसमें हमने various types of converters देखे थे, मतलब 2 types थे, एक variable impedance type भी था और एक voltage source converter based fax device था. तो ये क्या करता है, उन दोनों के coordination से एक हमने fax device बना दिया जिसके advantages हो गया reduced cost, reduced ratings. It's a simple concept. Control operational strategies भी आपकी obviously lower losses है, higher efficiency. So in a nutshell, we can say that hybrid power flow controller can be regarded as a cost-effective alternative to the UPFC. Okay.
And lower losses means which type of losses?
Lower losses तो वो आपके जो fax devices का एक जो मेन एम होता है वो ओवरऑल लॉसेस को रिड्यूस करना होता है. तो एज स्पेसिफिकली ये कुछ अलग से लोअर लॉसेस नहीं है, फैक्ट्स का ही एक एडवांटेज है स्टेबिलिटी का. नाउ there are various topologies of HPFC which are available and which have been proposed. One of the topology which I am going to explain today is this. In this case, what they have done is they have taken one shunt capacitive control capacitance, and in addition to that there are 2 series VSCs which are actually half. So you might ask me a question that you have already used 2 VSCs in this case, so how is it different from your UPFC? It is not so. In case of UPFC you had 2 separate VSCs, but just consider it that one VSC you are taking and you are making it half. So there are basically 2 half rated VSCs in this case which are connected in series and they have this common DC link. So we can say that there is one classical, जो हमारा क्लासिकल एक शंट में हमारा इम्पिडेंस कैपेसिटेंस हमने लगाया हुआ है, प्लस इन एडिशन टू दैट देयर आर 2 series VSCs in this case. So by independently control of these VSCs as well as this shunt device, we can control the flow of active and reactive power. Okay. So as we can see from here that in the central of this HPFC, you have one shunt connected source of reactive power. So what is this? This is nothing but your shunt connected source of reactive power, and which is represented by BM in this case, and it represents the controllable shunt connected variable capacitance. Okay, and so we can also say that this is equivalent to your SVC. This is equivalent to your SVC, let's say, जो हमारा variable impedance type device था, हमने जो discuss किया था, and this is your VSC source, यानी कि आपका voltage source converter based device. So this is a combination of those. Now there can be various topologies. In some case, you can have these in shunt and this in series. That can be one topology. There are around 25 topologies which have been proposed by Babic. So what you can do is you can go search for patents by Babic for HPFC. You will get around 25 to 30 different topologies which have been proposed because they have only been proposed. उनको उन्होंने implement अभी तक नहीं किया है. So there is a lot of scope for you to work on this. So as I have taken in this case one topology, you can see from here. Am आपके पास इसका इक्विवेलेंट सर्किट होगा? है, वो मेरे को एक मिनट देना। उस पीपीटी में, लेकिन आपकी टोपोलॉजी एक्चुअली डिफरेंट थी ना, एक ही मेरे को देना है। ये आपकी,
मतलब एक दिखाया है जस्ट
ये तो मेरे पास है, इसका इक्विवेलेंट सर्किट ये वाला सिंपलीफाइड इक्विवेलेंट, ये नहीं है आपके पास?
ये ठीक है ना?
चलो कोई बात नहीं, ये तो मेरे पास इसमें है, तो मैं बता।
स्वैप कर दीजिए।
So in this case, what is happening is that these VSCs, they are basically exchanging the active power through this common DC link, as you can see from here, and the reactive power, it is provided by this shunt controller in this case. So basically you can have, by changing or by independently controlling these as well as these, you can have an exchange of the real and reactive power as well. And the basic of these have already been explained by Anjali ma'am. For example, in case you want to, if the voltage of this voltage source converter becomes greater than the line voltage, it is able to provide the reactive power. And if it becomes lesser than the line voltage, it is able to absorb the reactive power. This is about reactive power compensation. And what about active power? In case it becomes in phase with the line current, in that case, active power can be controlled. So similarly to this is nothing but your thyristor controlled variable impedance device. So by controlling the firing angle of those thyristors which are connected in anti-parallel, you are able to provide the variable impedance, which in turn provides the reactive power compensation. So those principles which we have studied in last 2 days of the various like SVC, STATCOM, etc., they are applicable here only because they are only used. Now what topology you can make it different is, like in this case, these VSC voltage source converter based devices, they are connected in series, and this variable impedance device is connected in parallel. What you can do is, you can connect this in series, make these in parallel. Okay, so this is how you can make the various changes. Now, if you have understood this concept, then I will be moving on to the MATLAB simulations. Now what we can do is, in this topology itself, there is lot of scope of this variable impedance device. Either you can connect an SVC, you can connect a STATCOM also, you can connect some other device also. So by doing all these different combinations, you can check the stability of your system. For example, this is the MATLAB Simulink based model of the HPFC configuration of the, in case you are using a SVC controller in place of that जो हमने अभी यहाँ पे कैपेसिटेंस की बात की थी, शंट कनेक्टेड डिवाइस की बात की थी, तो यहाँ पे अगर हम इसको रिप्लेस कर दें एक एसवीसी से, स्टैटिक वार कंपनसेटर से, so that becomes one topology. So let us name it HPFC D1, let's say. ठीक है, तो यहाँ पे आपका ये क्या है, this is your VSC1, this is your VSC2, they have a common DC link here, and your SVC is connected in parallel or in shunt to your whole system. So let us call this configuration as HPFC D1. Okay. Now we will implement this HPFC D1 into our single machine infinite bus system. Now this is the single machine infinite bus system in which sending end side पे हमने अपना HPFC जो है वो लगाया है. This is a single machine infinite bus system. यहाँ पे आपका synchronous generator है 200 MVA का 3-phase transformer है which is stepping it up from 13.8 kV to 230 kV. So आपकी जो rated voltage है वो 230 kV है और infinite bus is represented by this RL source 30,000 MVA का 230 kilovolt source का. And what we do is we provide a 3-phase fault at this side at the receiving end. Okay. Now after applying this 3-phase fault at the receiving end, let us see how this HPFC will behave or how it will make the stability of the system. So this is the variation of the rotor angle for the SMIB based system which is equipped with HDFC1. That is the first topology which we have discussed. We have taken the fault clearing time as 0.1 second. ठीक है, so 0.1 second fault clearing time देख करके we have made this table in which critical जो आपका fault clearing time है वो different उससे आपकी जो rotor angle delta है उसकी value we have seen, the time taken to attain the stability we have seen, the maximum value of overshoot we have seen, and the value of rise time also we have seen. So as can be seen from this table, the delta value remains almost constant. आपका delta की value almost constant रह रही है और आपका जो maximum value of overshoot है that is also almost 25 degrees. And the rise time, it is basically increasing with the increase in the value of the fault clearing time, and this आपका जो ये जो time taken to attain the stability, it is also almost 9, 10, 11 के बीच में रह रहा है. Now what you can do is that in the case discussed, we have seen wherein the HPFC it was connected at the sending end. So what we did is we also put it in the midpoint, we also put it at the receiving point. Similarly, different combinations we can take is we can create the fault either at the sending end, midpoint, or a receiving end. So accordingly, a comparison was made by making all these combinations, and the value of critical clearing time, it was noted. It is almost like sending end में 0.233, midpoint पे 0.2, and receiving end पे आपका ये values आ रही हैं. And as can be seen from here, the system turns out to be unstable when your value of fault clearing time is 0.2167. So this is your critical fault clearing time is almost 0.2. Now, in this case, this is a second configuration in which we have replaced our SVC with a shunt compensator. Our next expert has come, so I will just hurry up. So in this case, what we have done is we have replaced the SVC with a shunt compensator instead of that, and it is applied at the receiving end itself on the single machine infinite bus system, similar to the SVC. And then we noted the various values of delta, time taken to attain stability, maximum value of overshoot, rise time, etc. And we found again in this case the delta value is almost stable, the maximum value of overshoot is also stable, the rise time increases, and the value of time taken to attain stability, it is also almost stable. Similar to that, again we placed it at sending end, midpoint, receiving end, as well as the fault was created at sending end, midpoint, receiving end, and the value of critical clearing time was noted. This is a third kind of configuration in which the SVC was replaced by STATCOM. So see what our main aim is. आप मतलब अगर आप इस सारे उसका एक gist देखेंगे तो क्या है कि एक हमने हमारा SVC based controller तो लिया है, which is अब इस केस में हमने उसको सीरीज में ही किया है. शंट में हम SVC से रिप्लेस कर रहे हैं, STATCOM से रिप्लेस कर रहे हैं, सीरीज कॉम्पनसेटर से रिप्लेस कर रहे हैं. So we are just replacing it and we are checking that how our HPFC will behave when it is put at the sending end of the SMIB based system. So in this case, we have replaced that by a STATCOM controller. So this is our third configuration on the SMIB based system. And again, the various values, they are noted. Again, we can see that the delta remains almost constant and the value of rise time increases and the value of overshoot degree, it is almost constant. And the system becomes unstable at 0.2168. So this value is almost like 0.21 के ही आसपास हमारी हर configuration में रह रही है. Again, various locations of HPFC were changed as well as the fault was also put at various points. So this is another configuration in which in the series we have put 2 SSSC and 1 SVC in this case. So hybrid कैसे है इस केस में? आप सारे combinations अगर देखें hybrid कैसे है? One is your variable impedance type converter, the other is your voltage source converter. But the only difference is that in case of a UPFC you have two VSCs only of high rating. But in this case what you have done is you have taken one voltage source converter, split into two VSCs, and in the case of your shunt you have taken the classical or your SVC. This is the main gist of your HPFC. Now this is similar. Now okay, what you can do, what more you can do? As I said initially, that you can see the various topologies which have been proposed by Babik. You can go to that. He has filed a patent. You can search for the US patent by Babik for HPFC topologies. He has proposed around 25 topologies. आप कोई एक topology ले लीजिए, उसको आप SMIB based system में भी लगा सकते हैं, आप उसको multi machine infinite bus system में भी लगा सकते हैं. ठीक है. Then as one of the participant, he asked the question also about the optimal location. अभी तक तो इसमें optimal location was hit and trial, like उसको एकदम sending end में लगा दिया, mid end में लगा दिया या receiving end में लगा दिया. But one more area of research can be, you can use optimization tools in this case for optimal location of these HPFCs. इस पे भी बहुत काम जो है वो हो सकता है आपका. और okay, any doubts? Any doubts?